Hello, class. Today is an exciting moment for all of us. We are going to have presentations by the companies formed by our students in CE 101, Introduction to Civil Engineering and Career Planning. In the beginning of the semester, you were asked to form your three-member companies, and then as part of CE 101 term project 1, I choose my own structure. You were asked to choose one large civil engineering structure and search and present the planning, design, and construction stages of this structure. Well, this was an opportunity for you actually to investigate a structure from the planning stage to the completion stage and see all the stages between this beginning and end, and then design or develop your own understanding for the future structures. You have at least 3 more years to go, and you can design your own career during this process. Well, the structure can be anywhere in the world. Only you had to make sure that you can find the relevant information about the structure to investigate here. Well, every company here has chosen a different structure. And this structure actually fits your own dreams. Maybe you are going to design, construct such a big structure in the future. Well, this can be a tall building, a dam, a bridge, a tunnel, a lifeline project. Well, this is the opportunity for you. Your turn project will include all the key stages from structure's beginning to its end. Scheduling, safety, cost estimating, design, construction, quality assurance, construction inspection, risk management, environment, and more. Of course, you have some certain deadlines here, and so far you achieved those deadlines, and now today will be your opportunity to present what you did during these investigations, during fulfilling your dreams. Well, during the process, preparation, and every stages, you showed your work and you clearly indicated us that you are not one night student. Actually, you plan the things from the scratch, and then continue to the end. Well, your project, of course, were asked to include following main topics: title page, contents, abstract, introduction, location, need and purpose of the structure, financial planning, budget, economic and other considerations, design and construction planning, construction stages, quality management, safety concerns, environmental issues, conclusion, and references. Well, we also provided you guidance about each one of those. And of course, references, very important. If you take any information from somewhere, a web page, a book, a magazine, you have to provide the reference. It's very important in all for work. Well, with that, now we can proceed actually with your presentations, and we are all excited to listen the companies, what they did and what are their dreams. Well, now let's start.
In this part, I will talk about the features of the Osman Gazi Bridge. The bridge is the fourth bridge with the longest main span in the world. Another feature is that domestic and foreign companies take part in this project. Also, the bridge is located close to our university. For this reason, we found it easy while doing research, and the bridge was built in a very short time. In this photo, we see the model design of the Osman Gazi Bridge. Location, need, and purpose of the Osman Gazi Bridge. To travel between Gebze and Izmir, it's necessary to cross the bay. However, this road is quite long, so the purpose of the bridge is to shorten this road, as seen in the pictures. Financial planning, budget, economic, and other consideration. The picture shows the main project of the Osman Gazi Bridge. The highway project is $6.5 billion. And also the cost of the Osman Gazi Bridge is 19% of the cost of the entire project, which is equals to $1.2 billion. Finally, in this picture, we see the tolls of the Osman Gazi Bridge according to vehicle types. Thanks for your attention. My presentation is over. Now I leave the floor to Muhammed Mahfuz.
Thank you, Batuhan. Hello, everyone. I am Muhammed Mahfuz. I will tell you about the design and construction planning, construction stage, and quality management of our project. The bridge foundation was laid in July 2013, and it was put into service on 30 June 2016. The main project is a highway, and it is 420 km long. The total length of the bridge is 2,682 meters. The length between the two towers is 1,550 meters. And the length of the side span is 1,132 meters in total. The towers of the bridge are 252 meters long, and the distance between the tower columns is 30.10 meters. Also, the bridge has 6 lanes. This part about construction stage. In this project, the total excavation is 199,000 cubic meter. The concrete used is 196,000 cubic meter, and the steel used is 83,400 cubic meter. 104 blocks were used on the steel legs, and 113 blocks were used on the steel leg of the bridge. The weight of each block on the steel legs is between 130 and 160 tons. The weight of each block on the steel leg is between 230 and 400 tons. We found some photos about construction stage. North Cajun buoyancy operation, driving steel pills to the seabed, bridge steel shaft manufacturing in Tuzla, and steel deck placement procedure. In this project, a special plan for quality management has been created. This plan has been carried out through 2 separate departments. These departments are quality assurance and quality control departments. In this picture, IHI infrastructure systems suspension bridge general organization chart is seen. Also, in this picture, bridge quality department organization chart is seen. Thank you so much. Listen to me. I leave the floor to Mehmet Kaan Süzer.
Hello everyone, I am Mehmet Kaan Süzer. First of all, I would like to thank Batuhan and Mahfuz for their presentation. Today, I will tell you about safety concerns and environmental issues. The safety concerns section is based on 2 different issues. These are the training procedure and the quality assurance and quality control procedure. There is a training given to the workers who will work in the first stage. At the other stage, there is control and supervision of any action taken in other parts. In the table, you can see the types of training in the training procedure and what these training types include. An unfortunate incident occurred on March 21, 2015. One of the guide cables of the Osman Gazi Bridge was broken. The construction of the broken cable was done again between 31 May and 4 June. There was no loss of life during the accident, but Japanese engineer Kishiroichi, who held himself responsible for the incident, so committed suicide. In this section, I will talk about the environmental problems faced by Osman Gazi Bridge and the measures taken. Osman Gazi Bridge was built by curving towards the west in order not to damage the ecosystem of the Ersek Lagoon. You can see the curve given to the bridge in the picture. 195 pieces of steel piers of 2 meters diameter were used in the foundation of the bridge. A gravel foundation of 3 meters thickness was built on this piece. Thus, during the earthquake, the foundation of the bridge cajon became freely movable. In the table, you can see the limitations imposed depending on the wind speed. Our presentation is over. Thanks for your participation. If you have any question, please ask.
Okay. Thank you very much. Was it exactly 6 minutes also?
Yes, before 6 minutes. It is less.
Okay. Now let's have a question.
Can I ask question, teacher?
Who is speaking?
I am Ömer. My name is Ömer.
Ömer, okay.
What are the factors in choosing the Osman Gazi project?
Hello again. As I said at the beginning of my presentation, we choose the Osman Gazi Bridge project because of its proximity to our university and the recent completion of the project will facilitate our research.
Thank you.
You're welcome.
Okay. Any more questions or one more question? Yes, Ömer.
Was the project necessary for a region in terms of the opportunities it offered?
The bridge was built at a really great cost. However, it has many advantages for those who used in the bridge. Considering these advantages, it is a necessary project for the region in our opinion.
Thank you very much. Now, I ask you actually to get into ders kutusu system and give your grades. Can you see? This is group 1 autumn. Second group.
System. Now it is your turn.
Bir saniye. Paylaşıyorum ekranımı. Geldi mi ekran hocam?
Yes.
Hareket ediyor mu? Yok değil mi? Hareket ediyor.
No problem. Go ahead.
Hi, my name is Ömer Yılmaz, and this is my group STEM construction. Today we'll talk about planning, design, and construction stage of Burj Khalifa. Firstly, Burj Khalifa is a multi-use building that you can rent an office for meetings, or you can have a meal in the restaurants, or you can spend night in hotels rooms. And of course, I don't even need to say it is the tallest building in the world. Okay, I'll start with risk management. Risk management helps you to identify and evaluate the risk you may encounter while doing your job. This way, you can minimize or solve your problems. As you can see, they created a rating system for final tables. I will come to that. There are two tables. One scaling the effects, and the other one is scaling the frequencies. Final table. This table shows you everything about risk, including the possibilities of their occurrence and these results if occurred. For example, solar radiation is very common incident, and its results could be catastrophic. Finance and budget. Burj Khalifa cost $1.5 million, and there are 20,000 people with salaries ranging from 500 to 1,500 AED. By the way, if you want, you can visit Burj Khalifa for $35. Timeline. Excavation started in 2004. They reached level 150 in 2007, and finally opening. Okay, Ömer, your turn.
Hello everyone, my name is Ömer Beyaz. Today I will try to explain design, safety and quality control topics to you in this structure. The first of all, I want to talk about design. The tower was designed by the American architectural company SOM. They designed Burj Al Khalifa inspired the desert flower Himenocalis we can see in this photo. It consists of a Y-shaped pattern. The outside of this building consists of 26,000 glass panels and has no sharp corners. The second, I want to talk about safety. All the systems we have mentioned here are the main security systems of this structure. All systems are available in the tower. There are special shelter area in area 25 floors. We can see in this photo. These rooms are not affected for 2 hours during the fire. The final, I want to talk about quality plan of Burj Al Khalifa. Quality planning in Burj Khalifa occurs in two different ways. We can see the quality plan in this photo. In this structure, generally, quality control applications are mostly based on the temperature, pressure, and water absorption capacity of the concrete. Thank you for listening to me. I leave here to Yusha Armak.
Thank you. Hi everyone, my name is Yusha. I will talk about three topics. Firstly, I'm starting with construction. Burj Khalifa's construction had 7 important things. These are components, durability, wind, transportation in building, construction speed, and security. Because of time issue, I will talk about one thing. I think it's most important thing, the security. They solved that problem with 9 shelter rooms. Also, you can see kangaroo crane in that photo. This thing is used for speed. Secondly, I'm talking about environment topics. As we know, Dubai is a desert and very flat place. After Burj Khalifa's building, downtown move around to building, as we can see in that photo. And last topic is construction inspection. Burj Khalifa is most powerful building against natural disasters. It has 200 embedded columns. It has antenna 1.8 meters long and last 15 floors completely made by steel. Thank you for listening. Now we can answer your questions.
Okay. Any questions?
I have a question, Professor.
Go ahead, please.
What was the biggest problem encountered while building this structure?
Sesim geliyordu şu an. Alo.
Yes, we can hear you.
Okay, I will answer to that. it was very hard to pump concentrate to top floors because it is a very tall building, and it was very hard to pump concentrate to upstairs. I guess.
I have a question.
Okay.
Go ahead. Go ahead.
Why did you choose Burj Khalifa?
İsteyen var mı? Cevaplayayım mı?
Fark etmez aslında. Ben de cevaplayabilirim.
Tamam, istiyorsan cevapla.
Okay. Because it's tallest building in the world, and also we can find information about it easily, so we choose it.
Okay. If there is no any more question, then you can give your points for this group. Okay. Meanwhile, we can continue with the third group.
Bridge. The group name is Bridge.
Merhaba hocam. Sesim geliyor hocam.
Yes.
Sunumu görebiliyorsunuz şu anda.
Hocam çok yankı var. Bir arkadaşımın mikrofonu açık herhalde.
Ben konuşacağım da o yüzden.
Evet.
Tamam. Hello everyone. We will talk about Empire State Building, and I will explain the purpose and
We cannot hear you.
Sorry.
Okay. Now.
Hello everyone. We will talk about Empire State Building, and I will explain the purpose and cost of Empire State Building. After the Empire State Building was built, it was largely empty for many years, and many floors remained unfinished for a very long time. The Depression was on, and New York City was glutted unneeded office space. For many years, the Empire State Building was viewed, at least from an investment perspective, as a white elephant. The owners, essentially on a lark because they were financially desperate, decided to open one of the roofs for viewing to the public. The Empire State Building has several roof sections since it is tiered. These ended up being wildly popular and extremely lucrative. It cost a nickel to go to what became the observation area, and people are still going there to this very day. The hate tourist brought in so many nickels that it kept the building from going bankrupt for 10 years. It took the economy to recover and the building to be filled with tenants. The cost of the building was about $41 million. As the Great Depression significantly labor costs reduced. The Empire State Building took 18 months. The Empire State Building cost 57,000 tons of structural steel, 48,000 cubic meters of concrete, 10 million bricks, and the involvement of almost 3,500 workers on site on peak days. Wills and Friedman. Thank you for listening to me.
Hello everyone. I will explain the design and construction part of the presentation. The length of the Empire State Building was 443 meters with the antenna. Empire State Building has 102 floors and designed in Art Deco style. In 1929, Raskop and partners bought a property for their new skyscraper. Raskop hired Shrevland and Harmon, the architects of its new building. The Waldorf Astoria Hotel had to be demolished before construction of the Empire State Building began. A loan of $27.5 million was received to start construction. A structural steel contract was signed to excavate the site before the demolition of the hotel was finished. Two 12-hour shifts consisting of 300 men each worked continuously to dig the 17-meter foundation. Small pier holes were drilled into the ground to concrete foundations. Builders placed the first steel columns on the completed foundations. The steel profiles in the contract were produced in a steel factory and transported to the site. It took just 3 days to produce, move, and set the profiles. The first steel skeleton was installed on 1 April 1913. 210 columns were used in the structure. 50,000 steel beams carried the weight of the building. The construction process was progressing very fast. In a period of 10 days, the builders built 14 floors. The steel structure was completed on 19 September, 12 days before the scheduled date, and 23 weeks after the start of construction. Empire State Building construction was completed in a record time of 1 year and 45 days. Empire State Building was opened on 1 May 1931. Thank you for your listening. Now Muhammed Shipshik will explain the quality management and safety concerns of the presentation.
Hello. Just a minute. Hello. I will present the quality management and safety concern section of the presentation. Actually, I will try. Firstly, I will tell you about the quality management section. Building the Empire State brings a lot of responsibility. The most important issue for the Stark brothers or company, you say, to pay attention to is time. The building had to completed in 18 months, and I think it's very short time for building. A detailed timetable was created to solve this problem. You can see the timeline in the table on the sides. In my opinion, the Empire State is a landmark for skyscrapers because it is the fastest completed skyscraper. It's just 18 months. And second part, as civil engineering students, we have to think about safety in every field we work in. Skyscrapers must have many safety criteria. As your building rises, the effect of the horizontal and vertical forces that you need to solve increases. And the Empire State Building has experienced many earthquakes and storms to date. And the building has not been affected by these disasters. We know that it was interesting information about me. We know that a plane crashed into both the Empire State and Twin Towers. After this incident, the Empire State was not destroyed, but Twin Towers were destroyed. Researchers attribute this to the ratio of concrete and steel used in the building. The plane crash did not minor damage to the building because 60 and 40% concrete and steel was used in the Empire State. Thank you for listening to me. You can ask the question if you have a question.
I've got a question for Aziz. What is the Art Deco style?
I will explain Art Deco style. Art Deco style was used in the Empire State Building, and Art Deco style straight and sharp lines, geometric shapes, aerodynamic forms, and bright colors stand out in the buildings. Empire State Building is the most magnificent Art Deco skyscraper in the world. Thank you for your question.
Can I ask a question?
Go ahead.
Who is she?
Beyza
Yeah.
Nur. How many
Right.
people worked on the construction of this building?
I can answer the question. I'm not sure because there was an economic crisis in America, 1930. It was büyük buhran. I don't know meaning in English. Büyük buhran. It was a crisis. I think because of the crisis, everyone wanted to work in construction of the Empire State Building. But I guess more than 3,000 people work in construction of Empire State Building. Thank you for question. You're welcome.
Nihal has a question, I think. Nihal Coşkun, do you have any question?
No, teacher, I have no question.
Okay, because I see raise your hand actually. All right, let's continue with the next presentation. Thank you very much. Muhammed, Aziz, and Hakan. Let's continue with the next one. Molos.
Ekran paylaşıyorum.
Go ahead, please.
Geldi mi acaba?
Can we start?
Go ahead.
Hi dear friends, my name is Ahmet and our group name is Molos. Today we are going to present you some research about Golden Gate Bridge. Firstly, I want to provide you some general information. The Golden Gate Bridge have 235 meters height and there are 6 lanes for vehicle traffic on it. It is currently the 7th longest suspension bridge in the world with 2.73 kilometer length. If we need to list our other research under the titles, we can list them as we can see in this page. Let's start with our first title. The Golden Gate Bridge is suspension bridge over the Golden Gate Strait at the entrance to San Francisco Bay in California. The bridge connects San Francisco with the northern areas of Marin County and the more sparse settlement, Napa and Sonoma Valley. Actually, there are 2 purposes of the bridge. This bridge was built to solve problems such as insufficient transportation between the 2 sides and the slow growth of the city. Actually, that's all for this title. Our next title is Finance, and Ogeday, go on.
Thank you, Ahmet. Financial planning, budget, economic and other considerations. The Golden Gate Bridge was built at a time of unemployment and hunger for $35 million. This bridge built weighs 887,000 tons, 600,000 rivets, the last of which is pure gold. Hold together the footrails of towers and beams. $400 million were also spent on the restoration of the bridge. One of the interesting features of the bridge is that it's famous for its suicide. A lifeguard filed project was created to prevent suicides. The cost of this project is $76 million. This file saved the lives of 19 people. Let's talk about design and construction planning. In 1921, Joseph Strauss presented a plan for a bridge that would cross the Golden Gate Strait. By the year 1929, consulting engineers Mosif and Ammon convinced Strauss to accept the fully designed bridge plan we see today. Individuals from 6 counties in Northern California voted to fund the Golden Gate Bridge. Strauss assigned engineer Ellis to work with Mosif as a team. Test runs without computers were done through figures. They confirmed these figures through tests on a 1:56 scale steel tower model. Our next title is construction states. Ahmet, go please.
Under this hearing, we will talk about the construction stage of the Golden Gate Bridge and its difficulties. Can you turn off your...
We cannot
We
hear
can't hear you.
you.
Sorry. Sorry, but the first step of construction phase is design engineering. In 1929, consulting engineers Leo Mosif and Aman Stavros designed the Golden Gate Bridge. The other construction phase was the construction of the foundation of the bridge towers. For this, it was necessary to working under the water, and at this point, the divers would come in. To build the southern tower structures, divers played a critical role. In order to install the abutments of the bridge, the foundation had to be completed first, and the foundation were formed with the help of the divers. On the other hand, a huge oval-shaped concrete barrier of the fender was planned to protect the bridge feet from ship crashes. The 44,000 tons of steel in each tower were produced. After the concrete works were completed, the installation of the steels for the South Tower began in January 1925 and was completed in just 6 months. The last piece of overall structure, the highway deck structure with its pavement, was in place 19th of April 1927, about a month before the bridge was opened. In the end, the wonderful bridge is completed. The bridge was designed to be strong and durable, but constant maintenance and improvement is required to make it a permanent momentum. Our next title is Quality Management. Yes.
Hi everyone, I will talk about quality management and safety concerns. In the construction of the Golden Gate Bridge, everything from the construction workers to the bridge itself does valid. Science security is at forefront. They have done all the work that can be done in the cleanest way. The most suitable materials were used in the construction of the bridge. Workers have been wiped as human beings and their safety prioritized. The highest quality work that can be done without any expense has been done. And safety concerns I talked about. There were really many security considerations in the construction of the Golden Gate Bridge in San Francisco. Before this project, bridge construction works or bridgemen had been constructed reckless, the rebels who worked without any safety precautions. Joseph Strauss' safety innovation and equipment included a safety net underneath the entry bridge during roadway construction. 19 men fell into the net accidentally, yet none of them died. This group was famously called the Help Vital Help Club. The Golden Gate Bridge wasn't the first big job that required fall prevention and other safety equipment, but it was the first big job to fire employees who didn't use the safety gear. Strauss safety regulations were constructed to be most rigorous in the history of the bridge building. Here's sampling of the required safety equipment. Workers used safety lines. Edward Bullard created an industrial hardhat weird on the job, and he designed a sandblast respiration helmet that the works wore, and special glasses and face cream were prepared to block the rays coming from the sun. Special jets were prepared for the workers. Crews were supplied for a hangover, and on-site field hospital was provided. The safety net was structured on the bridge. Even with this precaution, 11 men died during construction, including 10 who lost their lives when a section of the scaffold fan struck the safety net. Thank you for listening.
It took 8 minutes. Please don't do that. Okay, next time. Next groups.
Thanks for attentions. Do you have any question?
Yes, I have a question. When the bridge were being designed, did they think another design, architecture or engineer?
Yes, actually there was, as we mentioned, a presentation in 1921, engineer Joseph Starus presented a design for a bridge to cross the Golden Gate Strait, but the design is not like it.
Thank you.
I have a question.
Go ahead.
What is your reason for taking this project?
Actually, we don't have any specific reason. We choose it because it fits the homework parameters. That's all.
Thank you.
That's
All right. Thank you very much. Let's continue with the next presentation. John Tulin. And don't forget to give your scores, in ders kutusu for the presentation.
Can you hear me?
Clearly.
Okay. Hello, as Jonathan Company, we will talk about the Midfield Terminal building project, which was built as a major addition to the Abu Dhabi airport. Midfield Terminal building was established between the two runways of Abu Dhabi International Airport. The biggest question that draws our attention during our research is, why was it desired to build a new structure between the two runways of an existing airport? We reached out to the engineers working on the project and asked this question during our interviews. The answer lies in Abu Dhabi's future goals. Abu Dhabi aims to make the country a transit hub for long-distance travel and thereby achieve economic growth. So what should be done and what should be considered in order to reach this goal? First, money. When the MTB project is completed, it will increase the annual passenger capacity of Abu Dhabi airport from 12 million to 45 million and become the largest structure of Abu Dhabi Emirates. The project required huge amount of money and effort. Therefore, no single contractor company intended to enter the project alone. 6 consortiums, including giant companies such as Samsung, Hyundai, and Kumho, made bids and wanted to get the tender. When all offers were evaluated, the consortium consisting of Turkish Tower Construction, CCT, and Arabtech got the tender. The total cost of this project, which is planned to last 49 months with 16,000 workers, was expected to be $2.9 billion. And let's talk about design. The first striking feature of the building is its X-shaped design. The X-shape of the structure was designed not only to look aesthetically beautiful, but also to reflect the cultural and geographical values of the country. The MTB project is in the middle of geographical elements that the Emirates sees as its own values. This situation was a great reason to construct and design the arms of the X to face these geographic regions. The arms are represented by 4 totems in the center, designed as a turquoise facing the sea in the north, yellow facing the desert in the south, red facing the city in the west, and blue facing the oasis to the east. Besides the aesthetic and cultural factors, the most important reason why the structure is in the form of an X is that it serves the purpose we mentioned at the beginning. In this structure, which was built for transit use, the surface area and the instant passenger transfer capacity of the piers was increased thanks to the X shape. Also, the structure was placed between the two runways so that aircraft would approach the piers faster. Thanks for listening to me.
Hello, my name is Zid. Another title we have to talk about is Abu Dhabi International Airport's construction stage. Initially, Abu Dhabi Airport constructed in 1982 with 3 million passengers capacity, but later it couldn't respond to local use and external demands. So they decided to expand its capacity step by step. Midfield Terminal building is the major and The final expansion project started in 2011 with 7,425 piles. All foundations are deep foundations in this project. Also, by June 2015, the structural skeleton of the piers were formed, and its roof supported by 18 arches. As a result of testing phases of MTB was put into use in 2017. This airport has won a lot of certificates and awards, which are the proof of quality and standards. As you can see from the chart, there are lots of awards. One of them is ISO 9001. It is the most recognized and accepted series of basic quality management systems in the world. And another one is OSAS 18001. It is an occupational health and safety assessment series for health and safety management systems. Construction inspection. Regular examination of the construction process of the project is important both in terms of time and in order to ensure the regular and stable progress. In this project, tests were carried out to obtain information about the soil structure and soil components. The material which used in construction and the transportation phase were followed and documented. Examinations were carried out to ensure the harmony between the project drawing and the construction site. The inspections made in the construction area were reported daily, weekly, and monthly. And the final examination was carried out when the airport took its final shape. These are the material receiving procedure documentations to follow material receiving into construction sites. In Abu Dhabi International Airport project construction stage, they detected some injuries may exist in relation with environment, lack of PPE, injuries, or expenses which are not included by and chart to take precautions to them. There are three levels of their impact and 5 levels of their frequency. And the last subtitle is BIM. BIM is a collection of three-dimensional schemes used for the timely and smooth performance of tasks that different disciplines in the field need to work together. A moment.
Hello, I am Muammer Al-Turut. I will talk about the environment. Let me first tell you about the ESTAMA program, which has a great impact on environmental regulations. This program provides an environmental, economical, social, and cultural assessment of the buildings. In addition, it prevents the construction of structures. Midfield Terminal building, which has an important place in this project, was designed with environmental benefit awareness. As the temperature in the terminus area is growing environmental problem, the designers built a big roof supported by wide arches. This roof covers the structure, it provides shading and prevents moisture. On the other hand, there are many important applications such as carbon dioxide sensors, active stop and go system in luggage. Safety. Safety risks are one of the most important issues to consider before starting the project. In order to reduce the impact of risks during the midfield terminal project, all employees were given safety training. Active use of personal protective equipment in the field is always mandatory, and a form has also been prepared to report any accident. Conclusion. As can be seen, the effort spent on building in this project is enormous. Midfield terminal building requires the highest efficiency of different disciplines from start to finish. To summarize in the project, what are the methods using project, what different tasks different departments undertake on the same job, how to determine what to do in case of under-reserved station, and how to work all of these departments has been mentioned. Also, cultural and geographical factors were noted. Thank you for your attention.
Thank you. Let's have the questions.
Ahmet Pişkin. I think.
Sesim geliyor mu?
Yes.
What is the ESTAMA program? I don't understand that. What is ESTAMA program?
ESTAMA program is a program that provides environmental, economical, social, and cultural evaluation of the buildings to be built in the country. Is okay.
Okay, thank you.
Thank you very much. Let's proceed with the next presentation.
Steely.
Steely. Okay, let's go ahead with Steely.
Can you hear my voice clearly?
Yes, go ahead. We cannot see. Is everything all right?
I tried to share, but
Okay, now we can see your desktop. Okay.
okay. First of all, good afternoon, everyone. In this presentation, we will give you a brief information about the Öresund Bridge. On this page, you can see the topics we will talk about in the presentation. To make a brief introduction about the bridge, this amazing bridge turns into a tunnel and connects Denmark and Sweden. A part of the bridge is above water and it runs nearly 8 km. The remaining part of the bridge is a tunnel of 4 km. On this page, we mentioned some measurements about the Öresund Bridge. For example, each pylon is 203.5 meters and the distance between the sea and the road is 57 meters. Location, need and purpose of the structure. The Öresund Bridge connects Malmö and Copenhagen, which are located in Sweden and Denmark. The purpose of the bridge is to facilitate transportation between the two countries and to develop the cities of Malmö and Copenhagen economically. On this page, you can see all the expenses that made for the Öresund Bridge. The money spent on everything, including tunnels and bridges, together with government aid, with $2.6 billion.
Hello everyone. I guess everyone can hear me. I will continue the presentation. Design and construction planning. The Öresund Bridge is a cable bridge with a 4-lane road and 2-lane railway. The total number of cable is 196 and these cables are made of steel. The radius of each cable is almost half a meter. Primarily the construction of the artificial island was aimed, then tunnel construction and finally bridge construction was planned. There are some photos about construction stage. You can see it. Next page. Construction of bridge. Most of the bridge structures, the bridge piers and bridge spans were built on land and subsequently thought out the bridge alignment by a large floating crane. The pylons were cast inside. Three main segments of the Öresund link. On the Denmark side, the link begins with a 2.2 mile underwater tunnel. The tunnel emerges from the water into a roadway on 2.5 mile artificial island, Beberon, which appears as a bright white shape to the south of the natural island in design. The cable-supported horizontal bridge stretches 4.9 miles across the eastern part of the strait towards Sweden, making a thin white line across the image. This photo is satellite view of the project. Number 1 is underwater tunnel, you can see, and number 2 is artificial island and horizontal bridge, and finally number 3 is roadway.
Hello again, my name is Davutcan. And at this part, in safety concerns, we have two stages actually, and these are during the construction and after the construction, but all of them deal with safety of people. For instance, there is a mini seizure bridge under the bridge in order to ensure the safety of employees and passengers used in road maintenance works. Next page, please. And in this part, we have two important issues, and these are the damage to the marine population and the effects of voices on the bridge to the airport near the bridge. Next page, please, Ahmet. And the load transfer, it has bearings weighing up to 20 tons each, capable of bearing vertical loads up to 96,000 kilonewton in a longitudinal direction and up to 40,000 kilonewton in transfer direction. Next page, please. And in this picture, we have a picture about load carried by the crane and information about railway part of the bridge. For first picture about crane and second picture with about railway. Next page, please, Ahmet. The bridge has immersed tunnels, and each tunnel element is 176 meters long, 49 meters wide, approximately 9 meters height, and weighs around 57,000 tons. Next page, please. And we have some results after the bridge has done, and these results, employment has increased throughout the region. 1.8 to 3 million people are working in the region. Around 35 million people travel this road every year. Air pollution has reduced by 50% as it replaced ferry transport, and circular mobility has increased. Next page, please. For this page, you can check out our information about this presentation, and thank you for your attention. If you have some questions, we would like to answer it.
Thank you. Let's have the question.
Mehmet Kaan Sudan.
Evet hocam. Can you tell me what kind of isolator is used against the earthquake in this building?
Actually, we have no search about the earthquake of the Denmark and around Sweden. I cannot answer this question.
Thank you.
Thank you.
Maybe you can answer this question for the next.
Sure.
All right, let's continue with the second. Not second, but the next presentation. Beton.
Hello everybody, I am Oktay Soytürk. As company Beton, we will talk about the Panama Canal. Let's take a look at the topics we will talk about first in our presentation. I will explain introduction, location, need and purpose of the structure. Later, Mr. Halil will explain parts, financial planning, budget, economic and other consideration, design and construction and planning, and construction states. Finally, Mr. Furkan will explain part quality management, safety concern, and environmental issues. In this section, I will give information about the Panama Canal. This structure has provided significant conveyance to sea trade and travel. The construction of this canal was started by the French government in 1881 and was completed by the American administration in 1914. Thanks to this structure, savings have been achieved both economically and in time. In this section, I will give information about the location of the building and its purpose. The purpose of this canal is to save a great deal of time and distance to pass from one end of the continent to the other by water. The Panama Canal is located in Panama, the southernmost country in Central America. This canal is the waterway connecting the Atlantic Ocean and the Pacific Ocean. The Panama Canal has reduced ship travel from one end of the continent to the other by 2/3 in terms of time and distance. Can you continue from here, Mr. Halil? Thank you.
Thank you, Oktay. Today I will make my presentation to you under the 3 topics. The first one is financial planning, budget, and economy. Let's start to explain. The French began construction of the canal in 1881, but was stopped after 8 years. The investment made in this period is $287 million. The United States moved the rights of the canal from the French for $40 million. The total cost of the Panama Canal was $639 million. Another issue is the design and construction planning. The design and construction planning of the Panama Canal was made according to the canal locks system. The locks in this canal have the same length, width, and depth. The locks in this structure are constructed in pairs to allow ships to pass in both directions at the same time. We see in the photo on the right the towing locomotives. Another important point is the breakwaters. Breakwaters have been built at both entrances of the canal. These breakwaters protect the ports of entry and the structure from violent storms and strong waves. Finally, the subject I will tell you is construction stages. The first attempt to build this canal was made by the French leader Ferdinand. About 22,000 workers died due to illness and accidents within 9 years of the project's induction. During United States construction, John Wallace was the first chief engineer of the Panama Canal. Colonel George Goethals, another important name, completed the construction of the Panama Canals. Nearly 5,000 people died in the United States project management. Thank you for listening. I leave the word to my friend.
Thank you. Hello everyone. My name is Furkan. I will tell you quality management, safety concerns, environmental issues topics. Let's start. First, the quality management. The Panama Canal government has some principle of quality management. First, to ensure effective management of project within the time, cost, and quality required to meet the needs of our customers and company. Second, to encourage the effectiveness of contracting goods and service process within the time required to ensure satisfaction of our clients. Third, ensure the availability of standardized product in warehouses by managing inventory levels, analyzing demand, and communicating with the customer. This picture is the original text of the quality management principles. Safety concerns. We can say that the Panama Canal is safe for both customers and workers, also visitors, because the Panama Canal implements essential prevention. For instance, they have ISO 9001 security certificate that is given by International Standard Organization. And the canal management implements a safety and health training program for canal employees. Environmental issues. The canal management care about environment. Also, they are obliged to care because the Panama Canal basin supply water about 95% the Panama country needs. The Panama Canal has ISO 14001 environmental management certificate. The Panama Canal management to protect water from and leaking from ships established 3 treatment facilities. This picture, one of them. The Panama Canal administration cleared 7,703 hectares of land of weeds and drainage ditch beds. The Panama Canal administration has afforested 209 hectares of land. Thank you so much for listening to us.
Well, thank you for the presentation. And now, if we have any questions, let's take them.
Onur Genç.
Why did you choose the Panama Canal?
We choose it because the canal is the longest canal in the world. We like it.
All right. Let's continue with the next presentation.
Brick.
Brick. Okay. Company brick.
Hi everyone. My name is Batuhan Kocabaş. Our company is the Brick, and today we will talk about Brooklyn Bridge. I'm gonna present the first part that have a 3 titles. The titles are Informations, Design, Construction of Brooklyn Bridge. First, the informations. The Brooklyn Bridge is the hybrid cable-stayed suspension bridge in the New York City, spanning the East River between Manhattan and Brooklyn. It was the longest suspension bridge in the world when it was completed. It has become a attention point of tourists in New York since opening day. It was first suspension bridge made of steel. It was so important point. Any architect or engineer didn't use steel in suspension bridge construction before John Augustus Roebling. He revealed potential of steel in the bridge design. That's why using steel has become popular in the world. General and numerical some information. Designer, constructed by, design, total length, width, height, longest span, clearance below, opened. Other page. Why was Brooklyn Bridge was built? Brooklyn and New York considered 2 separate cities. Because of harsh condition of the estuary and tides. The condition made it difficult to cross. That's why the only mode of transportation was crowded and unsafe ferries. Ferries could not to be used to winter because East River freezes. The other reason is reducing crowd and pressure in New York City and making Brooklyn a valuable area. John Augustus Roebling's bridge design. John Augustus Roebling presented master plan 1867. The bridge design that is suspension bridge have the 2 neo-Gothic towers. It contains roadway, rail, and walkway for pedestrians. In order not to block the traffic of river, he designed the middle of bridge to bend upward. He designed the overall superstructure. You can see this plan, overall superstructure, the next page. Towers of bridge. For several years, the bridge neo-Gothic towers became the tallest structure in Western Hemisphere. Roebling intended the bridge towers and the prominent arches and serve as grid monument and the adjoining cities of New York and Brooklyn. Each towers contained a paired Gothic reveal pointed arches throughout which the roadways run. They are built limestone, granite, and resin-dale cement. It is the construction chronological order. Construction started the 2nd January 1870. The first location of Brooklyn site was built. Occasion is water tank weighting structure is generally used to work on the foundation of the bridge pier and construction on the concrete dam. Brooklyn Cajun was fired. When the Manhattan was being built, it was covered with the fireproof iron plate to prevent burning like the Brooklyn Cajun. You can see the third picture, the plan of the Cajun. And other Brooklyn Towers reactor had the 27 meter, 2 tower completed, first temperature wire, tension main cables. Low quality wires was used main cables. The wires were not changed, but supporting wires installed. Construction of superstructure, 500 tons short steel was used construction overall structure on roadway, which was completed. Thank you for listening. Your turn, Ali.
Okay, thank you, Batuhan. Hello, everyone. I'm Maner'dan. My first subject is security measures. Many diseases and safety problems have been encountered in the construction of the Brooklyn Bridge. The first of these is decompression sickness. The disease was first discovered by the project Dr. Andrew Smith. 3 workers and chief engineer Washington Roebling died of this disease. In other years, 3 workers fell from the towers and died due to security issues. Another incident happened after the bridge was opened to visitors. One visitor fell off the bridge after suffering an epilepsy attack. The reason for this is that the bridge does not have protection posts. As a result, approximately 27 people died due to security problems. Okay, next page. My second subject is cost estimation of Brooklyn Bridge. The cost of the bridge was announced as $15 billion in 1883. The cost table of the bridge has changed due to the changing exchange rates over the years and after the restoration works. In 1999, the redeck of the road was completed at a cost of $34 million. Finally, a $725 million spending plan was made for the rebuilding of the ramps and the repainting of the bridge between 2009 and 2011. Thank you for listening. Your turn, Özgür.
Thank you, Ali. Hi, everyone. I'm Özgür Saltık. Let's start with construction inspection and risk management. Construction inspection was very important for workers' life and health of project. Construction of the bridge started in 1869. The bridge was closed for vehicle traffic in 1974, and it was completely closed in 1980. Sucrose cable broke off in June 1981. One pedestrian died there. This event imitated restoration. Next page, please. Second issue is quality control of Brooklyn Bridge. Steel cables on both sides of the bridge began to bend in September 1877. This deformation which caused deaths and injuries. Only 5 of the 80 cables conformed to the standards. It was decided to add 150 cables. Next page. Last issue is environment. Brooklyn Bridge is the bridge in New York City that connects Manhattan and Brooklyn cities over the East River. Vehicles and pedestrians can use this bridge, but heavy vehicles can't use this bridge for height of bridge. In the restoration project approved in 2011, it was decided to add 150 steel carrier cables. Acid rain caused by environmental pollution is wearing down the bridge. Thank you for listening.
Thank you. Let's have the questions.
Have there been any accidents while running the project?
Okay. Yes, of course. For example, the last incident occurred 5 years before the end of the bridge. One of the main wires of the bridge broke off and killed 2 workers. Okay.
I have a question.
Go ahead.
Can you give details about Gothic architecture?
Gothic architectures are firstly seen in Middle Age of Europe. I think France is they have a biggest structure like the Notre Dame cathedrals or other cathedrals. It's have a biggest columns and biggest windows, rose windows. Bu kadar. Thank you.
Thanks.
Okay, let's continue with the next presentation.
Temples. 9.
Ekranı görebiliyor musunuz?
Yes. Clearly.
Hello, Professor and everybody. Our group name is Temples, and our group members Nihal Coşkun, Ayşenur Servi, Burak Berkegül. I am going to talk about introduction, construction stage, and quality management, and we are going to present the Shanghai Tower. Shanghai Tower, which height is 632 meters, is the tallest building in China and the second tallest building in the world.
Hello everyone, I'm Ayşenur and I will talk about location, need, design and the safety parts of the presentation. Shanghai Tower is in Lujiazui Finance and Trade Zone of Parung. We can see the location of the tower in this picture that we took from Google Maps. Now let's talk about why they needed to build this tower and what was the purpose of it. We can count 2 important reasons. First, Shanghai City has horizontal city plan so that people who work in that district were wasting their time in transportation. And second reason was traffic congestion and pollution by automobile exhaust that city had. All people working in that location were causing these problems to come together to meet. The purpose of the tower is to reduce all these problems with its sustainable vertical urbanism motto. Here you see some parts of Shanghai Tower. There are parts for offices, observation decks, retail places, but I will talk about that in the design section again in detail.
Hello everybody, I will talk about financial planning, budget, economic, other consideration and the environmental issues. The estimated cost of the tower is $2.4 billion. They had been planning the Shanghai Tower since 1993 because there were economic reforms in the late 1980s and the government realized that the city would need a major project to meet all its needs. After all this planning process were completed and the tower was completed, same problem arose with the tower. The most notable problem was the surprisingly low occupancy rate of the tower.
Shanghai Tower is designed by the Gensler Company. The main idea behind the design was to build a vertical city. In the first picture, we can see double-layer glass facade. With this double-layer glass facade, inside of the tower was illuminated with natural light, and every zone is filled with plants like here. In second picture, we can see the tower's curve. Shanghai City has strong winds, and Gensler designed the tower according to this situation. So they gave the tower this shape, as you see here. And this is the optimal rotation angle, which is 120 degrees to minimize the structural wind loads. With this shape, they reduced the wind loss about 24%. Also, they saved $58 million in materials. Inside of the tower is organized into 9 zones. Every zone contains about 12 to 15 floors. Zone 1 is the base level. It contains luxury boutiques, cafes, etc. Zones 2 through 6 are for offices. Zones 7 and 8 are for luxury hotels. Zone 9 is for the observation decks. These are plans of the some floors of the tower.
Construction of the building started in 2008. The main responsible of the project is Shanghai Construction Group. The construction crews laid the last structural beam of the tower in 2013. In 2014, the tower exceeded 600 meters. The internal construction of the tower was completed towards the end of 2014. The building started to be introduced gradually in 2016. And we can see the construction stage of the tower here. And while preparing this project, 20 basic procedures were defined initially. These procedures had to be revised in response to possible problems. The needs for components such as a red pile, steel structure, internal and external shear wall, and support system were identified for the multi-section working unit. For example, the pile forming process requires constant monitoring. It is necessary to ensure that there are enough control points to ensure the overall quality of the process.
The tower has high security precautions due to the many cultural artifacts and documents it has inside. Although there are so many precautions, 2 photographers climbed the tower illegally during construction, as you see in the picture, but they were caught immediately and brought down safely.
Since the building has a successful system in energy efficiency, it makes a positive contribution to the environment. The tower has a total of 43 different sustainable technologies. They use wind turbines to produce their own electrical energy in this photo. We can see the wind turbines of the tower.
Thank you for your attention. If you have any question, you can ask it.
Let's take some questions.
I have a question, Professor. Can I ask?
Yeah, go ahead.
This building has a little bit different design. Many materials were used in the construction of the building. So were there any difficulties in producing the materials?
I think that question is to me, so I can answer it. The shape of the tower required more than 20,000 wall panels, actually, with more than 7,000 different shapes. It was too complex and costly to produce these components with using traditional computer-aided design tools. So they applied the mass customization process with parametric software and laser measurement technology to produce all these wall panels and components. I can say.
Thank you so much.
You're welcome.
Yes, teacher. Did any problems occur during its construction?
I can answer it. Yes, in 2012, cracks started to form in the roads near the tower construction site. This was originally thought to be due to the weight of the tower, but turned out to be due to the ground collapse caused by excessive groundwater abstraction in the Shanghai area.
Thank you.
Batuhan Kürsoy.
What engineering techniques are used in the foundation of the Shanghai Tower?
Can you repeat it?
Of course. What engineering techniques are used in the foundation of the Shanghai Tower?
I don't know.
All right. If you don't have any answer right now, maybe in the beginning of next lecture, you please get prepared answering this question. Okay?
Okay.
The group temples.
Okay.
All right. We thank you, and now we proceed with the next one. This will be our last presentation for today, and we will continue with the others after this group.
XAE12.
Could you hear me?
Geliyor mu hocam ekran?
Yes.
Tamamdır. It is XA. Sorry guys, okay. Hello, it is XAA12. Today we will give you a general information about the Sydney Opera House. Sydney Opera House has become one of Australia's most important landmarks since it's opened. The building was designed by Danish architect John Utzon. The Danish architect won the Rc Architecture Award in 2023, of course, thanks to the Opera House. The Opera House was added to the World Heritage List by UNESCO in 2007. Let's talk about some technical issues. You can see the John Utzon's photo here. Scheduling. The state government is holding a competition for design of the building. Of course, John Utzon's wins the contest in which many candidates participated. And the construction of the Opera House begins in 1959. Construction work progressed in 3 stages. The first phase was the construction of the podiums. The second phase was the completion of the roof. And the third phase was the completion of the interior spaces. Interior spaces means iç mekan in Turkish. You can see all in the photo a view from the second phase of the construction. Design of structure. John Utzon designed the project without ever seeing Sydney. The bluish white, which it means mavimsi beyaz, shell of the Utzon's exterior is inspired by the depths of the ocean. 1,656,000 ceramic tiles were brought from Sweden for roof construction, as you can see here in the roof for white construction. And you can see in this photo plans of structure. The first is the first plan, and the third was the last plan of the Sydney Opera House. So in the last of my part, you can see all the interior and exterior view of the Opera House in the photos. The building has a total of 1,000 rooms. These include 5 rehearsal studios, 6 dressing rooms, 4 restaurants, 6 bars, and many gift shops. Exterior and interior means dış mekan and iç mekan, as you can see in the photo. Okay, that was my part. It is your turn. Construction of structure.
Thank you, Ahmet. Construction of the Sydney Opera House started in 1959, and the construction process took place in 3 stages. Next one.
Thank you.
The first stage took place from 1959 to 1963 and was completed with the podium construction. Next one. The second stage lasted from 1963 to 1967. The roof is completed at this stage. Next one. Upson had to resign due to structural problems in the structure. He was replaced by 3 Australian architects. One of them is Pietro in this picture. The third stage lasted from 1963 to 1973. The interior was built at this stage. The third phase of the project was continued by 3 architects who took office after Udson's resignation, and many changes were made in Udson's original design. Next one. After the construction is completed, the building is 183 meters long and 118 meters wide and covers an area of 1.8 hectares. Next one. And while the estimated cost of the building was $7 million, the total cost reached $102 million. Your turn, Efsun.
Thank you, Alp. And I'm gonna talk about some topics. Let's start with the safety part. Technology wasn't very advanced when it was implemented. Some workers even died during construction, but also there are some good points, like next one. The building was built to withstand a 9.0 magnitude earthquake. Next one. Firstly, I want to talk about financial part. Almost all expenses were covered by the returns of state lottery, and the design and construction process was unquestionable and high profile. Wanting to start work out of fear that the public might oppose that project, the government pressed for construction to begin before many structural problems were fully resolved. Next one. Unfortunately, the pillars built for the roof shafts were heavier than they should have been. Therefore, they were demolished and rebuilt, so the cost increased. Next. The building is covered with ceramic-coated concrete shells that need regular maintenance, and they subsequently changed this primitive and expensive technique. Sydney Opera House has been awarded by the Australian Green Building Council. They received this award for implementing a new waste program, increasing efficiency in water use and reducing the energy use. Thank you. I think I have a question.
Yiğit Cengiz.
Yes. Why was the structure awarded so late? Why didn't he get an award until 2003?
Because this structure wasn't completed until 1990s. It was completed at the beginning of 2000, so it received an award lately.
Okay, thank you. I got it.
Any more questions? Well, we thank the presenters today. I think we have to stop here because you have other classes going on after 3:30, as far as I know. Then with the remaining of the presentations, we will continue next week, right? I think we are doing well. You are doing well for being prepared as professionally as those presentations, and we will also see your reports as well. And we also thank maybe to your colleagues. You all participated in questions as well, so that's good sign. And don't forget to score your colleagues at Dersin system you are evaluating the presentations as a class. So thank you again. We will continue next week with the remaining of presentations. Well, our project one presentations will take place today, and you remember actually in project one you were required to choose one large civil engineering structure and search and present the planning, design, and construction stages of this structure. And you have options to make, to choose any type of structure. The structure can be anywhere in the world. The only issue was that actually you can find the relevant information about the structure for this term project. And also, every team has to choose a different structure. There are enough structures in the world. So we don't want you to present the same structures, and we make sure that you took or you worked on a different structure. And you have chosen different structures, tall buildings, dams, bridges, and it is quite interesting and exciting in that sense. Well, in your presentations, you are required to report all the key stages from the structure's beginning to end, including scheduling, safety, cost estimating, design, construction, quality assurance, construction inspection, risk management, environment, and more. These are just a few to name. Okay. And then now we will continue with our presentations. But there are some questions as far as I remember and from the last week, and we will first have the opportunity, or we will give the opportunity to our groups to make their preparation in answering those questions. And please go ahead. Nihal, I think you are the first to answer one of the questions from last week. Go ahead, Nihal.
Evet. Önce soruyu bir daha okumama gerek var mı?
Yes, please. It will be a good reminder.
Tamam. What engineering techniques are used in the foundation of the Shanghai Tower? Post-grouting techniques were used to reduce the length of the pile, thus economy in foundations and to get the required bearing capacity. The foundation system adapted for the Shanghai Towers, post-grouted board piles.
All right.
Hi, Professor.
Go ahead.
Actually, I have some research about earthquake in the Orison Bridge, about isolators. The question was about isolators, but I couldn't find anything about isolators in the Orison Bridge actually. Then I have some research about earthquakes in Denmark and Sweden. Actually, nothing about earthquakes in Denmark and Sweden, because the last earthquake in Denmark about 10 years ago actually, and that's all that I can find out about earthquakes, because there is nothing about earthquakes in the Orison Bridge actually.
Okay. Any more explanations from other groups? Ersun, do you want to say something? All right. If there are no any more explanations or questions, then we can continue with our groups today.
First company is green today.
Okay. Is everybody, is group here?
Sunu açıldı mı?
I think it's coming. Yes.
Tamam. Hello everyone, I'm Şevval Biş. Today, we as the Green Company will tell you about Petronas Twin Towers. Construction of Petronas Twin Towers in Kuala Lumpur, Malaysia. The architect of the Twin Towers is Cesar Pelli. It was the tallest skyscraper in the world between 1998 2004. It is 425 meters long and consists of 88 floors. The construction planning of the Twin Towers started 1992, took 1 year, and started construction in 1993. It was opened with a ceremony by the Malaysia Prime Minister on 1st of August 1998. Project engineers had difficulties due to the problematic ground in bedrock, and the said construction was moved 60 meters. The construction consists of 120 meters deep concrete floor. The Twin Towers are supported by a ring of 16 cylindrical columns of high-strength reinforced concrete. External face of the tower clad in stainless steel and vision glass. These antennas at the top of the towers are 73.5 meters long and 176 tons is weight. A total of 83,500 square meters of stainless steel extrusion and 55,000 square meters of laminated glass were used for the coating. Now Duygu will continue.
I will talk about the design and safety parts. The architect Cesar Pelli was inspired by the light and climate of Kuala Lumpur when designing the towers. The architect also includes Islamic culture in his design. As seen in the image, the shape used in plan of the towers, that is the 8-point star, is a shape found in Islamic culture. There is a sky bridge between the towers. Apart from connecting the towers, the sky bridge fills the gap between the towers in terms of design. At the same time, as seen in the image, the horizontality of the bridge emphasizes the verticality of the towers. Thus, the height of the tower surveils again. If I need to speak for the security part, there are smart systems in both towers. The fire safety system covers the affected area and expels the polluted air. In addition, there are fireproof paint and stairs in the towers. Since Malaysia is an area of seismic activity, the towers are designed to be earthquake resistant. The towers have the world's largest foundation and plates that move under pressure. At the same time, the towers are constructed of high-strength concrete to reduce any vibration. I leave the words to Onur.
Petronas Twin Towers is the 15th most expensive tower in the world. The cost of the towers is $1.6 billion. The skyscraper, which was tendered to two different construction companies, also witnesses the competition between these two companies. These companies are Hazama and Samsung. This competition has been positive for cost of construction and time to finish. This structure of the building consists of dual system, consisting of reinforced concrete core wall system and exterior reinforced concrete columns. Reinforced concrete has been chosen as the primary structural material for the lateral resistance system. This table is the summary of the project. This structure of the concrete used is shown in this table. Production of high performance concrete, the British standard, are utilized as a basis for the contract documents, and high performance concrete used significantly in the project. The definition of high performance concrete utilized for the project includes high strength concrete, workability, and durability. The definition of high performance concrete used for this project is as summarized in this table. This table shows the properties of concrete. G40, G60, G80, these are types of concrete. The optimum mixture made is shown in this table. P3000N is water reducing. R1000 is super plasticizer. Thanks for listening to us.
Soru sorabilir miyim hocam?
Yes, in English, please.
Why did you choose the Petronas Twin Towers?
Because it's one of the tallest towers in the world and one of the most important symbols of Malaysia.
I have a question, teacher.
Go ahead, please.
What exactly is the purpose of the building, the Petronas Twin Tower, and what opportunities did the structure provide? Thank you.
Petronas Twin Towers were built to build the world's tallest multi-purpose structure in the center of Kuala Lumpur. This project not only served the needs of the people, but also became a symbol of their growing economic strength against the country.
Well, we thank you. If there is no question, then we can continue with the next presentation.
Professor, they must go to the desk system and give some grades.
I think they already know that. Please don't forget that, you know. You have to grade your colleagues as we did last week. In the ders kutusu system.
Group evaluations 2. I opened it.
Is it active?
Yes.
Okay.
Next group is construction. Next company.
Ekran paylaşımı açıyorum hocam şimdi.
Okay. Let's go.
Hi everyone. As the construction firm, we are going to talk about the Hangzhou Bay Bridge. And we can start with the location of the bridge. The Hangzhou Bay Bridge is located in China and it's a 36-kilometer long bridge connecting the cities of Ningbo and Jiaxing. Purpose of the bridge is straighten trade relation between the two cities and make easier the transportation between these two cities. And also it's reduced transportation cost and time. And you can see here the bridge. That's okay. Financial planning, budgets, and economic and other considerations. Cost of the bridge is $1.42 billion, which was covered by 17 non-governmental organizations in the city. Among these organizations, the Songjeng Group was the largest investor in the project. And you can see here the chairman of the Songjeng Group. And the environmental issues. The growth of impervious surfaces can reduce environmental sustainability. The transportation ways like highways, bridges, and railways can disrupt the natural balance. And during the construction of the bridge, the release of natural gas, methane gas, ensured the safety of the project, but at the same time, disrupted the natural balance. Emir will explain design of the bridge.
Hangzhou project's final plan lasts almost 10 years with the help of the 120 technical studies and more than 700 experts from all over the world. In project, the cable-stayed bridge design was used because it can resist adverse conditions, multidirectional currents, high waves, and geologic conditions. In total, 32.2 km cable was used in this project. The structure of bridge was designed to seismic criteria, so it will retain durability in earthquake, which magnitude is up to 7 on the Richter scale, and the Hangzhou Bay Bridge guarantee that it has 100 years of service life. The bridge has 36 km length, and the width of the bridge is 33 meters. Also, the bridge is 62 meters above the ground, so it can enable the fourth and fifth generation container ships to pass. Finally, it's a service center which is called Hayalinizdeki, and it is built in the middle of the bridge. The service center is built on an island due to avoid obstructing the sea current and in the bay. As you can see, Hayalinizdeki has a lot of opportunities, especially the lookout tower is getting attraction from tourists. From now on, yours will continue.
Construction stages. Many bridges use concrete piles to support the deck, but the Hangzhou Bay Bridge took a different approach and used steel piles. Two large cranes were used in the construction of the bridge, one for 2,200 tons and the other for 3,000 tons. These heavy cranes were used to transport large beams from shore to bay. The steel piles used were also transported using these cranes. Quality management. Hangzhou Bay Bridge is in the form of a rope-supported bridge. This form was chosen for this project due to the robustness of the rope-supported bridge in adverse conditions. The choice of bridge form and construction material was based on strength against all the different forces the bridge would encounter. Steel piles are resistant to tides. Steel is extremely strong against corrosion and therefore is the best material that can be used in beams. Safety concerns. The first of the safety concern was the difficulty of offshore construction. Another safety concern was corrosion of materials and cracking of any concrete components. The third safety concern for designers and engineers was the toxic methane gas field, located about 50 meters below the bridge. Engineers have found a solution for all of them. This is the end of our presentation. Thank you for listening to us.
Okay, thank you. Let's have the questions.
Teacher, can I ask a question?
Go ahead, please.
How long does it take to cross the bridge?
I can answer the question. If you drive at 70 km per hour, it will take half an hour, I guess.
Thank you.
Any more questions? Well, I thought actually it takes longer than that. Once I was on that bridge actually I was traveling from Ningbo University to Shanghai to the airport, and I thought it took longer than that. Anyway, okay, let's proceed with the next presentation.
Silva.
Merhaba hocam.
Hello.
Ee, Hocam bir dakika. Kusura bakmayın.
It's okay. I think this online system sometimes fail.
Ekran gelmedi Berkay'da.
Nasıl gelmedi? Anlamadım. Bir dakika. Ekranım gözükmüyor mu şu anda?
And now we can see, yeah.
Şu an gözüküyor.
Pardon hocam, daha demin gözüküyor zannettim. Sorry.
No problem. Go ahead, please.
Hello everyone. Today we will talk about our research about Braga Stadium with our company. Our company name is Sivu and consists of Berkay Gülal, Furkan Kösle and me. Firstly, I would like to talk about location, need and purpose of the structure. The municipal stadium of Braga is a football stadium located in Braga, Portugal, and the current home of Sporting Clube de Braga. This stadium is located within the sports park dome on the north coast of Monte Castro. This stadium was built especially for the 2004 European Championship, now hosting about 30,000 people for the Braga club's matches. This stadium also hosts a festival called Entero de Gata, organized by a University of Minho.
Hello everyone, I will talk about the cost of the Braga Stadium and other considerations. Built 2003, opened 30 December 2003, construction cost is 3.1 million euro. Architect Eduardo Soto de Moro, structural engineering AFA associate, general contractor ACE. The challenging nature of the terrain resulted in the cost of the stadium rising to 83.1 million euro. It is the fourth most expensive of 10 new stadiums built for Euro 2004 after Estadio de Luz and Estadio José Alvalade. The architect's success in the stadium has won 3 awards. The most important of these awards is the Pritzker Prize. He won the Pritzker Awards in 2011.
Three, design and construction plans. The floor consists of a constraint stand. C3545 mixed constraint is used. The vertical walls are highly strengthened and inclined at an angle of 15 degrees. Anconic threaded connection is used. The clamps were attached to the two ends of the walls, making it easier to connect the plates. Iron weight is reduced thanks to bevel gears. There are many steel rods with a span of 2020 meters. There is a wetted drain flowing into two main channels.
4. Construction stages. Constructor consists of 3 stages: roof, stand, the field. 4.1 Roof. The difficulties caused by the structural difficulty of the stadium roof were overcome by aerodynamic test and the right material selection. Full locked cable were chosen as it makes more sense in terms of durability and sizing. In order to minimize the problem caused by different deflection, precast boards slated on the cable with a minimum layer of the concrete casting were used. 4.2 Stand. The uprights are made from reinforced concrete. Visitors can circulate horizontally through 3 large circular openings. The stairs are in reinforced concrete and are supported between 2 uprights, spanning an open bay of 6.5 meters. 4.3. The field. Structurally, the zone underneath the field is formed by circular columns capped by circular sections of diameter 0.7 meters, which support the mushroom-shaped slabs of floor -1 and the ground floor.
Five, quality management. Braga Stadium is a very well managed stadium in terms of quality management. Aerodynamic tests and correct material selection have been made. The continuous monitoring program set up around the suspension ceiling measured wind, temperature, and acceleration over 8 months. 6. Safety concerns. Output model method was used as the difference from the dynamic test of the suspended roof in the Braga Stadium and subsequent correlation analysis. Numerical simulation and wind tunnel tests have been done. However, the structure has been said to be vulnerable to aeroelastic imbalance.
Environmental issues. There are three main environmental problems. The first is air pollution. The second is the problems arising from waste. The third environmental problem is the problems that occur during its construction. That is the most significant environmental problem for us. To explain, 1 million cubic meters of stone was removed during the construction of the stadium. The heavy equipment used in doing this and dynamites have released quite a lot of chemical gases. In other aspect, the materials used in the construction of the stadium also consume some of natural resources. Thank you for participation. If you have any question, we try to answer them.
I have a question.
Okay.
I see a photo on the page about the field. I see sloping rocks in the areas close to the stadium. Aren't the rock a security issue?
I guess it's difficult to prevent these rock embankments from slipping, but they are stabilized by bolting using high-strength steel bars. Therefore, they don't pose a security issue.
Thank you.
Any more questions? Okay, we thank you and continue with the next presentation.
Big company.
Big. Okay.
Can you share my screen? Can you see my screen?
Well, not yet. Oh, okay. Now we can see clearly.
Okay. Sorry.
We lost it again.
Denetim vermeye çalışıyorum da onu yapamadım. Bir dakika. Okay. Denetimi verdin ama çalışmıyor galiba şu an. Ben geçerim, sen başla.
Hi everyone.
everyone, we are Beyza, Gazel and Iram from the group BIG. In this presentation, we aimed at introducing the Eiffel Tower, one of the most visited buildings in the world in France. We intended to touch on the details of this structure that we all know about. Eiffel Tower is one of the country's most important cultural heritage. It is 300.5 meters high. This height is without antenna. However, it was unpredictable that things would get to this level when it was first built. When the project was completed, the license agreements were based on the life of the building for only 20 years, and it was anticipated that it would be demolished soon. However, this decision was abandoned after seeing how functional it was as a broadcast station and the number of tourists it attracted. The Eiffel Tower had been the tallest structure in the world for 40 years, but with the construction of the Empire State Building, this title of the tower was taken away.
Hello everyone, I'm Gaza. Today I will talking about location, need and the purpose of the Eiffel Tower, financial design and the construction planning. The Eiffel Tower is an important symbol of the Paris 100th anniversary of the French Revolution. It was built as the entrance gate to Expo 1889 exposition, which was held as the part of the year celebration. In the first picture, we see an aerial photo of this exposition. In the second picture, there is a poster of this exposition. At first, Parisians thought that the Iron Tower was very ugly, but today the Eiffel Tower is still very popular. Next slide, please. Financial planning, budget, economic, and other consideration. The construction cost of the tower amounted to about 8 million francs, and Gustave Eiffel estimated that it would be 7 million francs, but the cost increased. In addition, the French government covered only 1.5 million francs of these costs. Gustave Eiffel himself covered all remaining expense, but it's not a problem because the tower covered these costs with entrance ticket fees after opening. In the picture, we also see the entrance ticket price and the ticket queue. Next slide, please. Design and the construction planning. The French Ministry of Industry and Trade decided that the selection of the monumental work for the celebration would be held in a competition. Many projects participate in this competition, but 300-meter Iron Tower project won the competition. After the patent was obtained and the contract was signed, detailed drawings of the tower were made, and we see these drawings from the picture, and the construction of the project began. Thank you for listening to me. Iram will continue.
Hello everyone, I'm Iram. I will talk about construction stage, quality management and safety concerns. Construction began on January 26, 1887, when the foundations of the tower were excavated and ended in 26 months, a record pace considering the basic tools available at the time. All elements to be used in construction were prepared in the factory of Gustave Eiffel. In the construction of the tower, 18,000 iron pieces and 2.5 million rivets were used to mount them. This was a well-known technique under construction. The tower was built with wooden scaffolds and small cranes fixed directly to the tower. Quality management. The assembly of the tower was a wonder of precision of the period. The design was so successful that the top of the tower only moves 2 to 3 inches in strong winds. In sunny weather, the sun-facing side of the tower can expand and slide up to 7 inches. Safety concerns. Gustave Eiffel was innovator in addressing the risk of physical injury and death during construction. Tall buildings are completely closed and falls are limited to a single floor. This risk is reduced by using moving screens, guardrails, and safety screens. Therefore, only one death was encountered. It was also innovative in elevator applications, used an elevator that locks itself in place in case of mechanical failure. And finally, measures were taken for suicide attempts by placing iron bars at the exit points of the platforms. Thank you for listening to me. Beyza, please continue.
The Eiffel Tower is one of the most important landmarks in the world, and it sets an example in terms of energy efficiency and helps to protect the environment. It has embraced renewable energy as part of its renovation by installing 2 vertical axis wind turbines. The 2 turbines are placed 400 feet above the ground within the tower's latticework, so that are not visible from the street level. The turbines produce over 10,000 kilowatt hours of electricity a year, and it is enough to power the commercial areas on the Eiffel Tower's first floor. You can see the installation of the turbines in the pictures. To sum up, this tower made of iron is one of the most popular structures in the world. It is among the first monuments that come to mind in Paris today. More than 7 million people visit this iconic tower every year, and since the tower's opening, 250 million people from around the world have enjoyed all that the Eiffel Tower has to offer. Thank you for listening. It was all.
Professor, can I ask a question?
Go ahead, please. The floor is yours.
I didn't see information about the construction area. I will ask, what's the size of the area where the Eiffel Tower is built?
I think I can answer this question. Eiffel Tower is located in an area of 200,000 square meters.
Thank you.
You're welcome.
I have a question, Professor. Can I ask?
Go ahead.
I guess you didn't tell us, or I couldn't hear that. If you know, what is the total height of the tower?
I can explain this question. The total weight of the Eiffel Tower is around 10,000 tons, with 7,000 tons iron and other materials.
Thank you.
You're welcome.
All right. I think that's all the questions we have for now. Let's proceed with the next one. Next group.
Next group is 3E. But I want to say something, Professor. There are some students grading all presentations without watching. So firstly you watch the presentations, then give grades, okay? I wanted to warn our students again.
Yeah, how can you grade without, listening to the presentation?
They gave 100 or 90 randomly.
I think it's not fair.
Yeah. I will remove them. I think I should remove them. Maybe.
Yeah, please.
Okay.
My voice is clear?
Yes, go ahead, please.
Hi everyone, I'm Emirhan. Today we are going to make a presentation about Eurasian tunnels. While the tunnel foundation was laid on 26 February 2011, it was completed on 22 December 2016. During this project, we tried to give detailed information about all stages from the foundation of the project to its completion, includes the technique used, the material used, cost, effects in the magazine, and its contribution to the society and the environment. Right now, I will talk about the route of the tunnel. Tunnel will significantly reduce the travel time between two sides of the Bosphorus. As you can see, the entrance and exit points of the tunnel are Göztepe and Kazlıçeşme. While the full length of tunnel is 14.5 km, the length of the Route passed through under the sea is 5.4 kilometers. Likewise, in this photo, you can see two different parts of tunnel. Sea line of the tunnel passing through under the sea floor, and this line opened by the tunnel boring machine. I will continue to our presentation with benefits of the project. One of the most important benefits of the project is that traffic jam has been reduced. You can see the others and also most of these benefits happening along with reducing the traffic density. Let's move on to the cost. The project was realized with the build operate transfer model. As it is shown in this picture, the tunnel investment is totally $1,245 million. While the $285 million was provided by Yapı Merkezi, $960 million international loan has been provided for this project. That's the other one. In this slide, you can see the information about workforce. While 2,124 employees took part in the Eurasian Tunnel project, a total of 250 construction equipment was used in the construction. And these are some of the road construction stages of the photos.
Thank you, Emirhan. Hi everyone, I'm Enes. Now I will continue my presentation. In this slide, I will show the companies involved in the construction of the Eurasia Tunnel. Ataş was selected by the Ministry of Transport General Directorate of the Railways, Port and Airport Construction for the design and construction of any project. The Eurasia Tunnel passes under the seafloor of the Bosphorus. This slide is about the capacity of the Eurasia Tunnel. The daily capacity of the Eurasia Tunnel is over 100,000 vehicles. A total of 15.6 million vehicles passed through the tunnel on 1.8 million different places in 1 year. Materials similar to those used in the most construction were used in construction of this project. Unlike other projects, a tunnel boring machine was used in construction of this project. The length of the tunnel boring machine is 180 meters and its weight is 2,200 tons. In this photo, we see the exoskeleton stairs of the tunnel. Let's examine the tunnel boring machine in detail. The tool in this photo is a tunnel boring machine. It can carry all kinds of materials from rock to sand. The diameter of tunnel can be between 1 meter and 19.25 meters. In this photo, we see a table containing the features of the tunnel boring machine.
Hi everyone, I am Eren. After that, I will continue the presentation. In this slide, we will examine the Eurasia Tunnel with its dimensions, such as project length 14.6 kilometers. This figure shows us cross-section of the road from various parts of the Eurasia Tunnel and shows the distance above the route. Like any structure, the Eurasia Tunnel affected its surroundings when it was under construction. Now we will show you a short video about the Eurasia Tunnel and its environmental impacts. My friends and I tried to summarize the Eurasia Tunnel in numbers on this slide. This is how we summarized the general characteristics of the Eurasia Tunnel, but we prefer to wait a bit and read whatever part they want instead of reading from the slide here because we have trouble with time. If everyone look at, I pass the page. The Eurasia Tunnel is one of the few structures in the world with respect to both the techniques used and environment. For this reason, the project has been awarded by international respect organizations, such as Engineering New Record, the most successful tunnel project of 2016.
This photo shows a post taken after the award ceremony of the Eurasia Tunnel. Our presentation is over. Thank you for listening to us.
Thank you. Let's see whether we have questions.
I have a questions. Is there any damage of the tunnel to the environment, and is it safety?
Sorry.
We already determined the effects and environmental and damages in our slides.
I have a question.
Go ahead, please.
What is the passing fee of the Eurasian Tunnel?
The passing fee of the Eurasia Tunnel is kaçtı? 36.40 Turkish liras for cars and 54 Turkish liras for minibüs bus diyebilirim.
Can I ask?
Go ahead. No problem.
What makes the Eurasia Tunnel special?
Tunnel boring machine was used exclusively for the Eurasia Tunnel. It was the first application of the most advanced version of the tunnel boring machine.
Ömer,
Can I ask a question?
Go ahead.
What are the most important benefits in terms of environment and the money?
Maybe I can answer this question. The project shortened the travel times. By the shortened travel times, it reduced the emission amount and fuel consumption, and it also contributed to the national economy by reducing vehicle maintenance costs.
Thank you.
You're welcome.
All right, thank you. Let's proceed with the next group.
Team MSI.
Merhaba.
Hello.
Hello everyone, I am Irem. Today we will give you a small presentation about Flatiron building. Flatiron building is seen in the position at the intersection of two streets, and these streets are not perpendicular to each other. The building is 22 floors and 19 meters long. The building is called Flatiron because it looks like an iron. The Flatiron building has never been the tallest building. However, the building attracts a lot of attention from photographers and tourists. The building has become the symbol of New York. There are offices in the building. The area where the building is located is called the Flatiron area. Although the history of building is old, it also brings out various beautiful scenes as we see in the pictures. In these pictures, we see frames from the Spider-Man and John Wick movies. Of course, the building was not used only these two films. We examined the design and construction planning under various headings. Construction started in the summer of 1901 and rose faster than expected. There is a steel frame in the building. The frame of the building is covered with limestone and terracotta curtain wall. The building is fire resistant.
Hi, I am Mert. I will talk about risk, cost, and design for Flatiron building. First, the steel frame structure, then the limestone and terracotta envelope were added. The steel support allowed the building to withstand 4 times the wind force it could be expected to withstand. 3 years after its completion, it was decided to build a total of 22 floors, adding a basement to the top of the building. Next page, please. The entire understanding of the building is based on the principle of the classical Greek column, pedestal, main body, and capital. The building is covered in baggy limestone with copper-clad windows, the main body of which is pale and terracotta. The bricks were red when the first built. Next page, please. In this photo, we see the floor plan of the planetarium building, and mostly office apartments are available in the building. Next page, please. The entire facade is elaborately decorated with design and motifs reminiscent of French and Italian Renaissance architecture. The value of the 22-story planetarium building, which has been earmarked by the city for development into a hotel, is estimated at $190 million. The area where the building is located is known as the Planetarium Fuller area, with the building's own name. Next page, please. The characteristic of the triangular design led to doubt as to whether the building was sufficiently solid for survival. At the time of the building's completion, newspaper reports focused on the potential dangers with tunnel effect created by the triangular structure at the intersection of two main streets. But the Planetarium building withstood strong winds despite claims. Next page, please. After that, Selvan will continue.
Hello, my name is Selvan Aşbacak. New Yorkers paid an immediate interest in the building, making bets on how far the debris would come when the wind knocked him down, and nicknaming it the Flatiron because of the resemblance of the building with the plates of the time. In this photo, we see the back view of the Flatiron building. A quality management system, which is QMC, is a collection of business processes focused on non-consistently meeting consumer requirements and enhancing their satisfaction. It is aligned with an organization's purpose and strategic direction. It is superstition that it is the oldest skyscraper in Manhattan, and this title belongs to the Park Row building. And the processes as follows: the calibrations, internal audits, corrective actions, preventive actions, purchasing and supplier selection, and monitoring. These processes require the performance of these processes to be measured, analyzed, and continuously improved, and the results of this form an input to the management review process. And because of the shape, it became an icon of the New York City in 1966. It was listed among the National Historic Landmarks in 1979. It was designed as a monument of national historic importance in 1989. Nowadays, it attracts the attention of tourists with iron-like structure. And the Flatiron building is the first building to use a steel skeleton in its construction. Steel was only used for bridge construction at that time. The skill in using steel in the Flatiron building is that it narrows at an angle of 25 degrees upwards from the ground. At the same time, the building is quite successful compared to its non-classical design and irregular layout. And thank you for listening to us.
Professor, I have two questions. Can I ask?
Go ahead, please.
This building is a high building and very famous building. Has anyone ever committed suicide? And why does it look like an iron?
I can ask first. Yes, the building is high. It's 19 meters. According to the magazine, a woman attempts suicide.
Okay, second part of the question, I think there was two parts to that question.
I can tell again.
Go ahead.
Why does it look like an iron?
I can answer. Actually, the building is a triangular structure, but it looks like iron. It was called the iron building because actually it triangular structure, not iron.
Thank you so much.
Thank you.
Well, thank you. Let's proceed with the next group.
October Company.
Hi professors, hi everyone. We will present the Bahrain World Center. Let's begin. Next page, please. Next page, please. Professors, can you hear me?
Yes, we can hear you, but
okay. Baran, the second page, please. Second slide. It is an iconic landmark situated at the heart of financial and business hub, a perfect space to establish, grow, and expand your organization. Let's continue, please. Next one. The Bahrain World Trade Center forms the focal point of a master plan to rejuvenate an existing hotel and shopping mall on a prestigious site overlooking an Arabian Gulf in the downtown central business district. These are twin towers rising above a three-story podium development adjacent to the Sheraton Hotel in commercial business district of Manama, Bahrain. It forms the focal point of a master plan to rejuvenate an existing hotel and shopping mall, rising to 240 meters in height. The twin office towers create a dramatic focal point visible throughout the kingdom. The towers will built in 2008. $150 million was required to build Bahrain World Trade Center. It currently ranks as the second tallest building in Bahrain, after the twin towers of the Bahrain Financial Harbor. Next one, please. Please, let's go to next page. The structure is located in Manama, close to the King Faisal Highway. Some very popular landmarks such as Baraj Al Lulu, Bahrain Financial Harbor. Next one. Next one, please. The concept design of the Bahrain World Trade Center towers was inspired by the traditional Arabian wind towers, tapering towers with the three wind turbines. The elliptical platforms and sail-like profiles act as aerofoils, funneling an onshore breeze between them as well as creating a negative pressure behind, thus accelerating the wind velocity between the two towers. Wind tunnel testing has confirmed of the shapes and spatial relationship of the towers sculpts the airflow, creating an S flow whereby the center of the wind stream remains nearly perpendicular to the turbine within a 45-degree wind azimuth, either side of the central axis. This increases the turbine's potential to generate power whilst also reducing PHQ on the blades to acceptable limits during wind skew across the blades. Thank you for listening to me. Baran, continue after me.
Can you hear me? Hello? Can you hear me? We cannot hear you. Who is presenting, Baran? We cannot hear anything. Now, can you hear me?
Professor, it's coming so deep.
Yeah, we cannot hear actually. I don't know.
Maybe if you are using headphones, then you had better take it off. Baran.
What's the problem? Okay, I think if there is a problem there, let's continue with the other presentation.
Hocam ben kendi bölümümden devam edeyim mi? Arkadaşın sesi gelmiyormuş da. Bir türlü yapamamış.
Yani bitirelim o zaman çünkü vaktimiz çok yok. Devam et hemen o zaman.
Tamam.
Let's
Ben
continue. Okay, let's continue.
tamam.
Baran also can use his phone, mobile phone, to present maybe.
Can you see? Gözüküyor mu hocam?
No, we cannot see anything.
Şu an sanırım gözüküyor olması lazım.
Yes.
Okay. My name is Taha. I will continue. The two towers are linked via three sky bridges, each holding a 225 wind turbine, totaling to 675 kilowatts of wind power capacity. Each turbines measure 29 meters in a diameter and is aligned northwest, which is the direction from which air from the Persian Gulf blows in. Three horizontal axis wind turbines have been integrated into the building to generate electricity. The fixed horizontal turbine based on a model of the Bahrain World Trade Center, Blocken calculated that the towers would actually produce 14% more wind energy if they were positioned the other way around, or better still, suspending the wind turbines further back would have given a 31% higher energy output per year. Blocken discovered. The turbines were commissioned in 2007, and global interest was received from environmental and architectural bodies, media and private institutions across the world, with their distinctive instantly recognizable design and utility. Thanks for listening.
Well, it's hard to ask questions. I think we couldn't hear exactly, but
yeah,
if there are any questions,
I have a question, teacher.
go ahead, please.
What feature of this structure were you affected by?
Okay. Turbines of this structure caught our attention because we thought it was very smart to have turbines to generate energy between the twin towers.
Thank you.
You are welcome.
All right, let's continue with the next one. Thank you very much.
Skyscraper Company.
Şunu paylaşıyorum hocam, bir dakika. Yok. Geldi mi?
Yes, we can see.
Hello, professor. Hello, guys. Today we will tell you about our project topic, the Marmara Railway System. Marmara project, one of the most important projects in the world, is a project that doesn't pollute the environment by using high capacity electrical energy in order to maintain Istanbul urban life in a realistic way. To provide a modern urban life and urban transport. To sizes and to project the natural historical characteristics of the city. Location Marmara Railway project in the dependent submarine station is inscribed. Railway project in the world. The depend of the tunnel 60 meters and the length of the tunnel is 1 kilometers long. The aim of project is the crisis, the improving the transportation so they connected continue. Pardon. And Russia with China. Financial planning the project runs funded by GP, the Concern of Europe, development by the European Investment Bank. Next afternoon.
Hello, I'm Gamze. I'm going to talk about design and construction planning and construction. The idea of Marmara was put forward by Sultan Abdülmecit in 1860. The first design was made by Abdülhamid to the French engineers in 19th. This was different from the present design. Their ideas was making pillars on the ground of the strait and placing the tube on these pillars. This plan couldn't carry it out because of lack of techniques. In 1987, the first feasibility studies was carried out by the government. They conclude that making this project was technically applicable and cost efficient. After 10 years, they signed a funding agreement. The construction officially started in 2004 with geotechnical and bathymetric studies. The construction stage consists of 3 stages. The first one, BC1 top tunnel construction. The first phase The tunnel elements were made in Tuzla, then linked under the strait. This phase delayed for 5 years because of archaeological remains. The second phase was Serie 1 and Serie 3 stations modernization construction. Serie 1 is Halkalı Sirkeci Railway and Serie 3 is Gebze Haydarpaşa Railway. These railways were renovated and linked two continents with immersed tap tunnel. Also, this phase delayed for 6 years. The last phase is Serie 2 railway vehicle supply, 4,040 vehicles supplied by Rotam, and your turn, Murat Kurnaz.
Thank you, Gamze. Hello, everyone. I'm Murat Kurnaz. I will talk about quality management, safety concern, and environmental issues. Let's start with quality management. It's controlled by a separate unit for quality control. Civil engineers, electric and electronic engineers, mechanical engineers, and computer engineers work together in this unit. Secondly, I will talk about safety concern. And there are some concerns such as flooding, earthquake, fire or power outage situations. These concerns were considered and some precautions were taken. Finally, I will talk about environmental issues. There are some environmental issues. For example, traffic congestion, noise, vibration, dust, and sludge. Thanks for watching. You can ask your question.
Okay, floor is open to questions.
I have a question, Professor. Why did you choose this building?
Because we want to know the structure around us as an engineer.
Thank you.
Thank you.
Okay, let's proceed with the next one. Thank you very much.
3M company.
Hello, my dear friends and my teachers. I'm going to share the PowerPoint. Could you see my screen?
Yes.
Yes, today we are going to make a presentation about Milla Viaduct, and this presentation prepared by Yiğit Erdoğan and Esma Nur Al. Now I am going to show the contents. These are our topics, and this is the picture of the Milla Viaduct. I think it has a really nice view. And let me give some basic definitions about the bridge. This is the tallest bridge in the world and the tallest structure in France. And this bridge even 19 meters higher than the Eiffel Tower. This is a multi-span cable-stayed bridge completed in 2004. And this engineering wonder bridge designed by Norman Foster, who is an English architect. Esma, you can continue.
Hello everyone, I am Esma. I want to start with the location of the viaduct. Milo is a convenient base for exploring France's deepest canyon, the famous Georges the Tarn, the Georges de la Dorbe, and the famous blue cheese sellers in Rockport. Milo Viaduct in the northeast of the Midi-Princess area of the Occitanie region is a small Mediterranean-style town on the banks of the River Tarn in the Aveyron department, located on the Paris-Barcelona Mediterranean Transit Route, carries 4 lanes of the A75 autoroad. Under favor to this bridge, people can travel the 2-hour road in 45 minutes. You can continue.
Okay, and the next one is need and purpose of structure. As Esma just mentioned, Milla located on the Paris-Barcelona and Mediterranean transit route, and also the Milla on the A71 and A75 motorway. For this reason, there was an incredible tourist flow in summer times and passengers trying to cross over the Tan River. You can see the picture of the Tan River. It flows under the bridge. And they are losing a minimum 3 hours in the traffic chaos. And for this reason, an aesthetic bridge was needed, and that bridge wouldn't spoil the beauty of the viaduct. And you can see the picture, although the bridge is built, but there is still traffic, and you can imagine before the bridge. Now you can continue, ma'am.
Financial planning, budget, economic and other consideration. The cost of construction was approximately $393 million. The construction of the Milo Viaduct has also contributed to the positive growth of the economy in the city. After the viaduct was built, this region has developed economically and touristically. Rockport cheese sellers and Silvanus Monastery benefited. Yes.
Okay. The next one is design and construction planning. An excellent product of the collaboration between engineers and architects, the Milla Viaduct was designed by engineer Michael Verla, who is a French civil engineer, and Norman Foster. And I can easily say this bridge is a work of art because that combines function, aesthetic, and technology. The main body is the 2,460 meters length and 32 meters wide. And you can see the foot length of the bridge. And in this project, 127,000 cubic meters of concrete are used. In order to reinforce 19,000 tons concrete and 5,000 tons tension steel was used. The construction of the bridge is planned to be started on 16th of October 2001 and finished on 14th of December 2004. And this picture, you can see the bridge and the Eiffel Tower. The bridge is the tallest than the Eiffel Tower. And 3 basic elements were discussed in the planning of the construction stage. The first one is security, because it was very risky to build a 36,000 ton and a 2.5 kilometer motorway on 7 pier. And to do this, 250 meters above the Tan River. As our friends told 1 week ago, 34 people died during the Brooklyn Bridge construction in New York. As a result of such occupational accident, the construction team decided to build an entire highway deck on safe lands. The second one is timing, because the team had to finish the building bridge in less than 4 years. I think it's a record time. And also delaying a bridge for 1 day, the cost the company $30,000. I think it's a really huge damage. And the third one is design of this mega building should not spoil the beauty of the valley. You can see the night view of the bridge. You can continue, ma'am.
Quality management. Many factors must be considered in quality management. Firstly, facing controversy against high quality. Facing the controversy might give more delicate and detailed analysis and simulation. Another factor is communication. Effective communication is very important for the success project. Lastly, human resources. The human resources planning identifies the project targets. There are 5 quality high definition images. First picture, cable stayed motorway bridge. We can see a long motorway. Second picture is a piles, deck, pylons and shrouds of the motorway bridge. We can see the pylon and shrouds in more detail in picture 3. This is a view of the bridge, and last picture showing overlooking the cable stayed motorway bridge. With these pictures, we have examined the high quality properties of the viaduct. That's it.
Okay, and the next one is construction stage. The construction officially starts on 16 October 2001. And November 2003, completion of the first pier. You can see the pictures, the piers. And February 2003, the laying of the pieces of the roadway. And November 2003, the completion of the last legs. And you can see the celebrating the finishing the last legs. They are celebrating. And the second semester 2004, placement of the floors and poles, removal of the temporary supports. You can see the temporary supports on this picture. And this 14th December 2004, official opening by the government. And the next one is safety concern.
Many difficulties were encountered in the construction of the bridge. First problem is wind. This is a very compelling factor. Wind at a speed of 225 km per hour at the location of the bridge. As we see pictured, a very difficult cable network was used on the bridge. It consists of 7 steel poles with a weight of 700 tons and a length of 87 meters. The length of each steel pole is different from each other. That's it.
Okay, and the last one is environmental issues. Since the construction site is a viaduct and it has some environmental problems, such as the wind blowing, as Esma told, 225 km per hour. And another one is the rock of the construction are filled with voids. These voids also cause the possible landslides. Despite the warning, the geologists about the landslides on the construction continued, and the expected came true. The rocks had fallen around the P1 column. You can see the picture, and if you want, you can watch the video of the landslides on this link. And fortunately, nobody was hurt, and the construction continued more safely. And Esma, you can tell the last words.
I want to complete our presentation by giving brief information about viaducts, and not only make the Millau Viaduct an engineering marvel around the whole world, but also make the project management leave us a very fascinating picture. Millau Viaduct has become an exemplary project in the field of construction all over the world. Thanks for listening. You can ask if you have a question.
Yes, ask the questions. Thank you.
Question.
Yes.
What is the purpose of the bridge?
I couldn't hear you. Please say again.
What's the purpose of the bridge?
Okay, thank you. I can answer this question. As I told, the bridge area is a viaduct, and so the purpose of the structure is to cross the valley in the fastest and the shortest way, because the people are losing their time and at the traffic a minimum 3 hours. And there is also a river, Tan River. The people want to cross over the river. I think it's a problem. So the construction company wants to build a bridge over this viaduct. Thank you.
Okay.
Is there any question?
What benefits bridge has provided to this region and its people?
Under favor to this bridge, people can travel the 2-hour road in 45 minutes. And other benefit is this region has developed economically and touristically.
Thank you. Let's proceed with the next group.
Thank you, teacher.
Thank you.
MFP company.
Can you see my screen?
Yes.
Yes, we can.
Okay, so hello everyone. We are MFP company, and we are going to be introducing you today is the channel tunnel with Bülent Çakır, Harun Muhammed Emin Sade, and I, Harun Can Mesci. So let's start with the basics, the information about the channel tunnel. The channel tunnel, also referred to as the Eurotunnel or channel, is a 50.45 kilometer railway tunnel that connects Folkestone, which is a city in England, with Coquelles beneath the English Channel and the Strait of Dover. It's the only fixed link between islands of Great Britain and the European mainland. So if I need to say quickly, it connects British and French beneath the sea under the Strait of Dover. And if we need to mention its exact geological location and its lowest point, it is 75 meter deep below the seabed and 150 meter below sea level. At 39.9 kilometers, the tunnel has the longest underwater section of any tunnel in the world, and it's the third longest rail tunnel in the world, which means at this lowest point, there is a çarpmal, which means in Turkish, tebeşir katmanı. So for its entire length, they made it in çarpmal, which is a marvel of engineering, and is the thirdest longer being just 150 meters longer than the Yulhan Tunnel in South Korea. The speed limit for trains through the tunnel is 160 km per hour, which is an accident happened about this in 2008. Due to high speed, there was a fire broke out, and 12 people were poisoned by the carbon dioxide, but no one died. And if we continue with the entrance in England, it's the entrance from England in Eurotunnel. These are the trains who carries passengers, and the further one is the one which supplies and carries the goods. So let's continue with the construction stages. Digging starting in 1988 with tunnel boring machines, TBMS, which is for this construction, used all the tunnels. 5 TBMS dug from France, 6 TBMS dug from the UK, and they linked between English and the French Sea under the Dover. The TBM started work on the service tunnel first. This was so engineers could see what actual ground conditions were like. Like I said before, they found the çarpmal to build this tunnel. The 2 crossover caverns were built using access from the service tunnels. TBMs digging the main tunnels passed through the caverns and then plunged back into the chalk to carry on digging. My presentation is over. Now I am leaving it to Bülent.
Okay, Harun, thank you. Ground conditions at the French end were better than at the British end. This meant the French machines moved more slowly and that British TBMs dug more of the tunnels. Engineers used 2 systems of tunneling: cast iron segments bolted together and precast concrete rings. The TBMs excavated a huge amount of chalk on the French side. The chalk was crushed, mixed with water, and pumped island behind a special built dam at 37 meters height. On the British side, engineers used the chalk to build a landscape platform at the foot of Shakespeare Cliffs near the Dover. Now I will give brief information about infrastructure. The channel tunnel is the longest undersea tunnel in the world. Still, its section under the sea is 38 kilometers long. It is actually composed of 3 tunnels. You can see in this picture 1.2, each 50 kilometers long, bored at an average 40 meters below the seabed. They link Folkestone to Kakulis. Yes, go on, Emin, please.
Okay, thank you. Now I will talk about the service tunnel in the middle of the 2 tunnels. Service tunnel is 4.8 meters in diameter and is between the 2 rail tunnels 15 meters away from each of them. The service tunnel allows access to maintenance and emergency rescue teams and permit the evacuation of passengers in event of an incident. It also serves as access to ventilation of the entire infrastructure. It is therefore kept in a state of air overpressure and remains safe from fumes in case of fire in one of the railway tunnels for an optimum safety. Next page. In the picture 1.3 we can see the service tunnel. Also in the service tunnel, electric and diesel vehicles are used for maintenance and transport system. Next page. Finally, I will talk about the cost of the China tunnel. The cost of the channel tunnel and initial equity of £45 million was raised by CTG FM, increased by £206 million private institutional placement. £770 million was raised in a public share offer that included press and television advertisements. A syndicated bank loan and letter of credit arranged £5 billion. Privately financed the total investment cost at 1985 prices was £2.6 billion. At the 1994 completion, actual costs were in 1985 prices £4.65 billion and 80% cost overrun. The cost overrun was partly due to enhanced safety, security, and environmental demands. Financing costs were 140% higher than forecast. Thanks for listening to us.
Thank you. Let's have the questions.
Professor, I have a question.
Go ahead, please.
Why the engineers did use two different methods?
Okay, I can answer this question. Because they use different methods as there are different soil types. For example, soft soil and soft soil and hard soil. So they used different methods.
Thank you.
Thanks, you are welcome.
Okay, let's proceed with the next one. Thank you very much.
DMM company.
Can you hear my voice?
Yes.
Hocam.
Okay.
Ekran paylaşımını açıyorum da şu an.
Go ahead.
Geldi mi?
Yes.
Okay.
Okay. My name is Murat Keleş, and we, as Group DMM, we are going to present the Magdeburg Water Bridge, which is in Germany. Okay, in the beginning, I will brief you about the Magdeburg Water Bridge's history. Planning for the canal crossing dates back to at least the beginning of the 20th century, so it started in early 19th. Work on the Mittelland Canal, that's the German name, began in 1905 and continued until 1942. But it stopped because of the World War II. When the Germans losing the war, they were desperate, so they stopped. And after the war, Germany split in half, East and West Germany, and East Germany did not resume the work because of the Cold War. And then, when the Germans reunified, the re-establishment of major water transport routes made the water bridge priority again because they needed to develop the East German infrastructure. So they started again in 1998 with construction taking 6 years and costing 501 million euros. The water bridge now connects with Berlin's inland harbor network with the ports along the Rhine River. The aqueduct's tough structure incorporates 24,000 tons of steel and 68,000 cubic meters of concrete. Okay. The Magdeburg Water Bridge is located at northeast of Germany in the city of Magdeburg. It is on the Elbe River. The Magdeburg Water Bridge is a navigable aqueduct in Germany that connects the Elbe Canal to the Mittelland Canal and allows ships to cross over the Elbe River. The water transportation is much cheaper than the land transportation, so they built this. After the reunification of both East and West Germany, they need this type of structure to use their water sources for transportation. As I said earlier, they needed to develop East German economics, so they did this structure. The solution of a waterway junction had to complete with the idea of a barrage in the river Elbe but this was selected because of economical reasons and causing little damage to nature. My present here is done. I'm handing over to Furkan. Go ahead, please.
Hello. Today I am gonna talk about budget, design, and environment. Let's start with budget. Post the construction of the Channel Bridge, which took nearly 6 years and a budget of about 500 million euros, a steady route was established for the navigators. All in all, the route established connectivity between the inner located harbors of the city of Berlin along with those located by the River Rhine. The design of the building had a spatial signification. Spatial characteristics of the building are the pylons at the beginning, at the transition to the actual transfer of the Elbe, and at the end emphasizing the transfer of the Elbe in the flat land space. Besides, there is the spatial form of the columns. The columns are swung ship-like and rib-shaped and give to the bridge a unique shape, whereby the navigation referred task of the building is reflected. Environmental issues. Besides its excellent engineering, the Magdeburg Water Bridge is a good example of environmentalism. It is also proof that technology can keep water, air, and green intake and even protect green. Thanks for the listening.
Next page, please. Hello again, everyone. I am Furkan Tuzak, and I will talk about bridge safety. You know that this is a water bridge and heavily loaded ships pass. That's why you can say that the bridge should have a lot of load carrying capacity. By the way, I said this information actually correct, but it is not necessary because ships have no effect on the bridge. Engineers use the buoyancy of the water to reset the ship's load. According to Archimedes' principle, the buoyant force exerted by the liquid on an object completely or partially submerged in a liquid is equal to weight of the liquid with which that body is displaced. Since the ships passing over the bridge are in the water, they will displace the water as much as their own weight. Since both ends of the bridge are open, the ships will move the water as they move forward. Thus, since the lifting force will be equal to load, the load will be zeroed. Next page, please. When this project over in 2003, the transportation problem between East and West Germany solved, especially cargo ships and pedestrians transportation, provided this route is far more shorter than the old one. German people save time and money. Thank you for listening us. If any questions, we will try to answer it.
Thank you. Any questions?
Yes, can I ask, Professor?
Go ahead.
Why did it take so long to finish this project?
I can answer this. It's because when they started, the technology was not too good, I think, and the world wars and economic crisis, it's delayed too many times. And when the reunification with Germans began, they finally can complete this structure. So I think this is the answer.
Oh, thank you.
Well, thank you. Let's proceed with the next presentation.
BNKM, the last company.
So it is the last one?
Yes.
Okay.
Hello everybody, do you hear me?
Yes, we can.
Can you see my screen?
Not yet.
What about now?
Still no. Okay, now go ahead, please.
Okay, hello everybody. Today our group will give you a quick presentation about the Three Gorges Dam. This presentation is introduced by Mohammed Noor Al-Hamka, Abdullah Barash Yilmaz, and Kaan Kurday. Before we start our presentation, let me tell you a quick fact about the dam. The Three Gorges Dam in China holds back so much water that it slows the rotation of Earth by 0.06 microseconds due to a phenomenon called moment of inertia. The location of the dam. The Three Gorges Dam is a hydroelectric dam. It spans the Yangtze River by the town of Sandobing, located in Yiling District in Hubei Province in China. The Three Gorges Dam is the world's largest power producing facility and the world's largest hydroelectric dam. The purpose of the dam. There were many reasons for building the dam. One of the main reasons that the Three Gorges Dam was built to prevent flooding further downstream. Another reason why the Three Gorges Dam was constructed was to generate electricity for the country. And now my friend will continue from here.
Yeah, hello. Can you see my screen right now?
Yes, we can.
Yeah, hi everyone. My name is Kaan Kurday, and I am the second presenter of our group. Today, I will make you a presentation about the financial and design part of the Three Gorges Dam. And in this table, you can see investments for the dam. And as you can see, the total cost of the dam is 249 billion yen, which is equal to 37 billion US dollars. And by looking at these amounts, we can understand how big and high cost project it is. So the Chinese government has identified 4 internal sources to cover the expenses. The first one is the state of Three Gorges Dam construction funds. And the second one is power revenues from Gosuba Dam, which is also another dam in China. The third one is power revenues from Three Gorges Dam itself. And it means the government increased the electricity taxes in beneficial areas of the Three Gorges Dam since 1996. And the last one is the Chinese Development Bank. There are also external sources that are quite important. Canada's Export Development Corporation and Germany's Export-Import Bank and other international export credit agencies provided the early loan guarantees for the project totaling hundreds of millions of dollars. And the Shenzhen Development Bank signed a loan package with a German bank in 1997 for the purchase of tribunes and generators. And 2004, the Chinese Development Bank hired UBS, HSBC, Citigroup, and many other banks and companies to help raise another 1.5 billion euros from bonds. And now the question is, how efficient the Three Gorges Dam is the waste of money. Actually, Three Gorges Dam is one of the most efficient projects that the Chinese government has done, because it was estimated in 2009 that the construction cost would be recovered if the dam generates 1,000 terawatt hours of electricity in 10 years after. But in 2013, the full cost of the Three Gorges Dam was recovered. So it is much more earlier than they expected. The dam gets more than $7 billion income every year, in which the net profits reach nearly $3 billion. So we can see how it plays an active role in the Chinese economy. In the design part, the dam type is a concrete gravity dam with a total axis length of 2,039 meters. The dam crest elevation is 185 meters, and the dam maximum height is 161 meters. The generation structures consist of 3 powerhouses and 1 power station. And here is the plan of the dam, and you can see the flood discharge dam section in the center of the riverbeds, and you can also see the powerhouses. One of them is in the right, in the other one is in the left bank. There's also one underground powerhouse under the mountain. And that's all from me. Thank you.
Okay, I will continue from here to talk about the construction planning. The Three Gorges Dam had been planned since from 1918, which means like 100 years before its initiation. In 1992, the Three Gorges Dam construction was officially approved and the preparation work started. In 1994, the construction work on site started, and the whole project was fully completed in 2009. The construction stages had 3 stages. Before the 3 stages, there was a preparations from 1992 till 1994. After the approval of the dam, the preparations had been started, which include establishing the organization to manage the project, raising funds, designing the dam in details, commandeering lands, and migrating. The first stage from 1994 to 1997. The damming of the divergent channel was formally opened to navigation, and Yangtze River was successfully dammed. The second stage from 1998 till 2003. The construction of temporary ship lock was begun. The tunnel of ship lock was dug and began to pour concrete over. The construction of the fluid discharge embankment had been completed. The divergent tunnel of the Yangtze River had been successfully dammed. The biggest hydraulic turbine generator in the world had been successfully hoisted into position, and the permanent ship lock with double lane and 5-step was tested, and the reservoir began to store water. The final stage from 2004 till 2009, the electricity route which delivers electric power to Shanghai went into operation. All the 14 generating sets on the left bank were put into production, which was 1 year ahead of schedule. And in September 15, 2009, the actual experience of raising the water level to 175 meters was started. The multiple rules of flood control, electricity generation and navigation and so on would be brought into full play. Now my friend will continue from here.
Okay. Can you see my screen?
We can.
Okay. Hi guys, I'm Barış. Today I'm gonna talk about safety concern, environmental and quality management. Let's start with quality management. At the recent meeting of key managers for China's Three Gorges project premier, emphasized the high priority given to quality control. Quality is the life of the Three Gorges project, he said. The placement of concrete and its quality control are of immense importance. The central structures of hydroelectric projects are primarily concrete. 27.9 million cubic meter of concrete that will be used in a Three Gorges project. A total of 7 batching and mixing plants have been constructed to supply the concrete for the dam. Three Gorges covers a spectrum of activities including materials and concrete production inspection, placement inspection, schedule control, cost control, technical management, concrete materials management, and overall coordination. U.S. company Hangzhou Engineering has been providing quality assurance and quality control services for the Three Gorges projects since the mid-1980s. The 185-meter Three Gorges Dam has been one of China's most expensive and most controversial engineering projects, submerging entire villages, displacing millions of people, and disrupting ecosystems. Critics say it has also increased the earthquake and landslide risks in the region. Chinese experts have dismissed the rumors hyped by some Western media that the Three Gorges Dam, the world's biggest hydropower project, is at risk of collapse. And the earthquake administration saying that the dam is capable of holding far larger inflows that is seeing now. First conceived of a century ago a means of controlling flooding along the Yangtze. Three Gorges Dam displaced more than 1 million people, 1,500 villages, towns, and cities vanished as dam building flooded the area. The Three Gorges Dam, according to some, has a potential of the China's largest environmental nightmares. One of the most immediate environmental effects on the Three Gorges Dam has been an increased landslide activity. Landslide is the surrounding areas have been much worse than had been predicted, and dozens of people have already died as a result. Another major issue with the dam is the ways in which is affecting biodiversity and the area. Animal and plant life has been greatly threatened due to flooding in some habitat and water diversion in others. Furthermore, fragmentation of habitat. Thank you for listening to me. Mohammed will continue with the conclusion and we can take the questions.
So, in conclusion, the Three Gorges Dam project achieved its goals of controlling floods that have killed hundreds of thousands in the past, and deliver electricity for development of cities and improve inland transportation. However, success could have been achieved in a better controlled manner if the schedule and costs were managed using appropriate project management techniques. It was also the goal of the government to improve the concentration and livelihoods of population inland, as majority of the Chinese population were Eastern Seafront based. Thank you for listening, everyone, and we can take your questions.
Can I ask a question?
Yes,
Go
of
ahead,
course.
please.
Why did you choose Chinese dam instead of Turkish dam?
Mohammed, are you going to answer it or I can?
You can answer it.
Okay. It's world's biggest dam in the world, as we do it, because we decided that we can take more information in the internet. That's it.
I understand. Thank you.
Any other questions?
Well, this will conclude our presentations today, and for the course, we thank all the groups for their contribution, presentations.
Professor,
Yes,
can you hear me?
yes, Mohammed.
No, I am Baran. I'm
Baran, okay.
Yeah, there was a problem. I couldn't find out why, but now can you hear me?
Yes, I can hear you.
Can I do my presentation? I think it took 1 minute or something else.
All right, go ahead.
Okay, thank you. So can you see my screen?
Yes, we can.
Okay, actually I was gonna talk about what the structure includes, its design, construction, planning, and foundation. This structure includes a shopping mall, a hotel, a gym, and a restaurant, which includes food and beverage. About its design, it's 240 meter high, and these twin towers has got 50 floors. It has got curved and sail-like forms. 3 wind turbines supported on bridges, and finally, it's the second tallest building in Bahrain. Construction planning. The site has an area of 120,000 square meters, and this area contains landscaping, office buildings, anchor tenant, garden court, and car parking. The plan remodeled a hotel and a shopping mall in a prestigious area near the Arabian Gulf, and building its parking and mall area is 88,617 square meters. Its floor area is 16,500 square meters. About its foundation, each tower has a separate continuous piled rough foundation at basement level, and the loads acting on pile are predominantly dead loads,
imposed loads and wind loads. Individual piles were modeled in the finite element analysis as vertical springs. And that's the end of my presentation.
Well, thank you very much.
I thank you very much, Professor. I'm so sorry again.
No problem. Well, thank you for the good work and for the all presentations. And now we will conclude the presentations here. As far as I know, you have actually another lecture will start very soon. And we will communicate online for the questions related to this presentation or for any other questions that you might have. Okay. Have a good week. Take care.
Thank you, sir.